Welcome back. In this video I'll be solving Leetcode problem 33, search in rotated sorted array. There is an integer array now sorted in ascending order with distinct values. That's nice. And with a pivot index. So, and what do you want? Given the right number, the possible version the index of the target if it's nums or -1 if it's not nums. Okay, target was 0. Yeah. So kind of and it has to be log n. Well, I solved similar one, which was the minimum of rotated sorted array, also in this complexity. So what we can do, well, I take mid. If mid is greater than target, then for sure well, maybe first I would need to check if I would need to do the that check first. So check if because it's a difference if, well, maybe it's not, we'll see. So well, I can find the index of minimum, and then I could split and do two separate ones. So 3 binary searches, that should be okay, I think. Let's do that. So first find index of minimum. Well, not actually 3, I do 2 binary searches for this example. So find index of minimum. I do that, left is 0, right is length of nums minus 1, and while left is less than right, mid is left plus right mod divided by 2, and so when I search for the minimum, if nums of m is greater than nums of right, that means I am in the rotated part, and that means that left is m plus 1. Else, if nums of m is less than nums of r, that means that I'm either at a minimum or this. So now I found the minimum. And where is it exactly? Well, it should be I think it will get to it. Then so if m is equal 0 or nums of 0 is greater than. If m is 0 or nums of 0 is greater than target, then I know that my left is 0 and my right, and my right is equal well, if m is 0, left is equal 0, right is equal length of nums minus 1. Else if, that's the first one. Else if m is then not 0, then else if nums of 0 is greater than target, then again L is equal 0 and right is equal mid minus 1. Let's put m is equal 0 just in case. So alpha and third else, so nums of 0 is, well, other way, if target is greater than nums of 0, greater or equal. But if nums of 0 is greater than target, then left is equal m and right is equal length of nums minus 1. And while left is less than right, m is equal left plus right divided by 2. So if nums of m is greater than target, then right is equal minus 1. Else if nums of m is less than target, then left is equal m plus 1, else return m, and here return left if nums of left is equal target, else minus 1. What do you mean? Okay, it seems I cannot try it like that. I'm not sure where I got this syntax. Not really sure. Okay, what did I miss here? What did I miss here? So I had 3 and 1. I found, I guess. Did I find them? Print them. Did I find them here? I actually did not find M. So M was 0. Right was 1. Left was 0, right was 1, M was 0. If nums of M is greater than nums of right. Yeah. Well, actually, M is not 0 here, so that's my bad. From the previous one, I should have remembered that. If num is return, okay. So the last one, yeah. So if right is equal M, if right is not equal M, then, well, either way, M should be right, if I'm correct. Or M is left. Yeah, something like that. I did mess up this part a bit, so sorry about that. Okay. Yeah, nothing too crazy, just double binary search of one time complexity all of log n. Yeah, maybe I should have done some function for binary search, but yeah, even they're not even the same, so yeah. Okay, hope this was clear. If you have any questions or whatever, just write them in the comments, and I appreciate you for following this video, and see you in the next video.